So you've been asked for the derivative of f of x plus 1 all squared. And f of x was defined as 2g of 3 of x minus 1. So that means if this inner function this time is really x plus 1, then that means that x is also really x plus 1. So it's 3 times the quantity x plus 1, or 3x plus 3. That's really the inner function. So I've written this all down here. 2g of 3x plus 3 minus 1 all squared. Well, as I look at this function, I would think, hey, my u is really 3x plus 3. That's the very inside thing. V I would call 2 times g of u minus 1. Now you could have said v was just g of u, but this is going to end up with the same thing, and it saves one step. And then w is equal to v squared. So now I just need each set of derivatives. U prime is 3. V prime, since this is just a constant, I'll essentially factor it out and find the derivative of this. Well, the derivative of that is g prime of u. Now I'll multiply by that constant, minus 0, because the derivative of 1 is 0. So I'll erase that for simplicity. And my w prime is 2 times v to the power of 1, or just 2 times v. Now I will multiply all three of my derivatives, because that is the chain rule. 3 times 2v, but v was 2gu, and u was 3x plus 3. Still inside that parentheses, a minus 1. So this all was v prime. W prime will be 2 times v. Sorry, this should have been a g prime, not a g. So 2g of u. So I don't have a minus 1. It's just 2 times g prime of u. That was a small error that I just corrected. And then w prime is 2 times v, but v is 2, g of u minus 1, and u was 3x plus 3. So this is your entire answer for part B. If you wanted, you could multiply some things together. 3 times 2, 6 times 2 is 12, times 2g prime, 3x plus 3, times 2g, 3x plus 3 minus 1. But there's nothing wrong to go with that first answer.